Okay, this is the Unit 3, Lesson 3 video, and today we're in Chapter 7, Section 3 out of the textbook, and our lesson is on logarithms and logarithmic functions. So we're looking at a couple content standards. The first one deals with graphing logarithmic functions, intercepts, and behavior. That's the part of that content standard we're going to focus on. And the second content standard looking at effects of translations on graphs. Our mathematical practice that we're going to focus on is attending to precision. So in previous lessons we've found inverses of a function, and in this lesson we're going to evaluate logarithmic expressions and graph logarithmic functions. A logarithm is a new vocabulary term, also a logarithmic function. You've probably seen a log button on your graphing calculator before, but maybe you didn't know what it did or what it stood for. And that's what we're going to talk about in our lesson today. So our key concept, a logarithm with base b. So basically the concept here, it says let b and x be positive numbers and b cannot be equal to 1. The logarithm of x with base b is denoted, which means the way it's written is log base b of x, and is defined as the exponent y that makes the equation b to the y power equals x true. So in words, or that's in words, but in symbols, the way you can see that is written right here. Log base b of x equals y is true if and only if b to the y power equals x. So as an example, if you have log base 3 of 27 equals y, that means 3 to the y power equals 27. And then you just figure out y, and obviously in this case y would be 3, because 3 to the third power is 27. So our first example, we're going to just take a logarithmic expression and put it in exponential form. So we have log base 3 of 9 equals 2, and we just want to write that as an exponent. And so simply all that is you take 3 to the second power and it equals 9, just like this. And that's all there is to doing it. Okay, part B, we're going to write log base 10 of 1/100th equals -2 in exponential form. So again, this is as simple as saying 10 to the -2 power equals 1 over 100. Okay, check your progress. We're going to go through these pretty quickly. Part A, flip into the answer now, is choice B. 2 to the third power equals 8. Part B, we have log base 3 of 1/9 equals -2. And so looking at the answer now, that's going to be choice C. Okay, moving on now to example 2. We're going to take 5 to the third power equals 125, which is exponential form, and we're going to write it in logarithmic form. So remember that the exponent is the thing that's going to be on the right side. The base is the base underneath. It's a subscript. It's written below the line after the word log. And the answer of the exponential form is written on the left side. So we're doing log base 5 of 125 equals 3, which means 5 to the third power equals 125. All right, part B, we're going to take 27 to the 1/3 power equals 3 and write that in logarithmic form. So in logarithmic form, that's going to be log base 27 of 3 equals 1/3. Okay, some check your progress stuff. We're going to do 3 to the 4th equals 81 and write that in log form. And our answer for this one is choice A. Log base 3 of 81 equals 4. Part B, 81 to the half power equals 9. Write that in log form. And this time we have choice D, log base 81 of 9 equals 1/2. Okay, for example 3, we don't have an equation anymore. We have to evaluate a logarithmic expression. So this time we're looking at log base 3 of 243, and we have to figure out what that is equal to. So the first thing that we're going to want to do with this is to try to write this in exponential form. So we know log base 3 of 243 has to equal something. We're going to call it y. So then we put that in exponential form, which would be 3 to the y power equals 243. 243 is 3 to the 5th, so 3 to the 5th equals 3 to the y, which means y is 5. So the answer, when you evaluate log base 3 of 243, you get the number 5. Okay, check your progress. Evaluate log base 10 of 1,000. So it's 10 to what power equals 1,000? And we see that 10 to the third power is 1,000, so our choice is B. Okay, now we're going to look at the graphs of log functions. So the basic log function is f of x, or y, equals log base b of x, and b is just going to be some number. So if we see that b is greater than 1, we have a function that looks like this. As x goes towards 0, the function goes down to negative infinity, and as x goes towards positive infinity, the function approaches the value of log base b of that x number. Similarly, if b is between 0 and 1, the function just gets flipped over, just like we saw with exponential functions back in lesson 1. So as x approaches 0, the function goes up to positive infinity. So you see how basically we take this graph and we flip it over and we get this other graph. So the first thing we're going to do is graph a function that's log base 3 of x. So first thing you always want to do is figure out the base. In this case, our base is 3. Second thing we want to do is figure out points that are going to be on the graph. And because our base number is higher than 1, we're going to use these 3 points to sketch our graph, and we're always going to use these 3 points. We're going to use 1 over b, comma, negative 1. We're going to use 1, comma, 0, and we're going to use b, comma, 1. So we're just plugging in the number b. So we'd have 1/3, negative 1, 1, 0, and 3, comma, 1. We're going to plot those 3 points and connect them on a graph, and then we're done. So if we go to 1/3, that's about here. Let me draw this on the screen. 1/3, negative 1 would be about here. Then we'd have 1, comma, 0, which is here, and b, comma, 1, which is 3, comma, 1, which is here. And so you can see if we connect those 3 points, we're going to sketch the graph that they have shown in blue. Okay, this time in part B, we're going to look at log base 1/4 of x. So this time, our first step, identify the base, just like before. Our b value is 1/4. So what that means is our graph is going to be flipped over from before. So this time we're using the points b, comma, 1, 1, comma, 0, and 1 over b, comma, negative 1. And then we're just going to sketch those points on our graph. So if I go to the first point they told me was 1/4, comma 1. This is about 1/4, and we go up to 1. Then we have 1, comma 0. And then we have 1 over b, which would be 4, comma, negative 1. So notice that between example 3 and example 4, or example 4 part A and example 4 part B, both graphs will always touch the point 1, comma 0. So once we connect these 3 dots with a curve, we form the graph in blue seen on the screen. All right, check your progress. For example 4, we're first going to do log base 5 of x. You should immediately be able to rule out 2 of these choices because they don't go through the point 1, comma 0. And so now we see that our answer is choice D right here. On this graph, we go through the points 5, comma 1 and 1/5, comma, negative 1. For part B, we're looking at log base 1/2 of x. So notice how B is flipped over. It's between 0 and 1, so our graph is going to be flipped over. So we should immediately be able to rule out one of the graphs because one of the graphs is not flipped over. And once you get those 3 points that we always are going to look for, we see that the answer is choice A. We see the point is 2, negative 1, 1, 0, and 1/2, comma, 1. Okay, we're going to do the transformations of log functions in the next video. So this is the end of the first video. We're going to pick up with this concept in the next video.